Okay, in this presentation, this is to do with solving equations where logarithms are present. Okay, so if x squared plus 1 is equal to 3x, show that the log of x plus 1 minus a half of log x equals 1/2 of the log of 5. Here, log just means the natural log, or log to the base e. Okay, so I'm going to start off with not actually a solution, an exploration. Okay, so this is the key thing we should be starting off with. Okay, but what I'm going to do is actually try to work backwards because I think that'll be easier in this case. Okay, so I'm just going to slightly adjust things there. I'm just going to write half of log x as log of the square root of x, likewise log of the square root of 5. Okay, so just sort of progressing things there a little bit. Okay, so let's just take that down a bit. What I'm going to do there is apply some of the usual rules of logarithms. In this case, log of x plus 1 minus log of square root of x. Just rewrite that as x plus 1 over the square root of x. And that is still equal to the log of the square root of 5. So that means that x plus 1 over the square root of x equals the square root of 5. Okay? And what we can do here is then square both sides. Okay, so x plus 1 squared over x equal to 5. Okay, and now I'm going to I'm just going to pull that back into shot there again. There we go. Oops, a bit too much. Just cross multiply. Multiply both sides by x, so we have x plus 1 equal to 5x. Okay, when we evaluate x plus 1, what we get is x squared plus 2x plus 1. Okay, and that is equal to 5x. Okay, so I think you can see where this is going. So subtract 5x from both sides, or actually, do you know what? Subtract 2x from both sides. Okay, and so essentially I just sort of took a sort of very meandering step there, but essentially this is what I need to get to. X plus 1 is equal to 3x. And that is actually where we start off. And this is where our starting point is. So I just sort of done the question in reverse, but actually that's fine. So the as posed by the actual question, that's what we do. We just do it in reverse. Okay. So just look at the question again. There we go. Just get rid of that. It's just some notes in the background. Just clutter. So there we go. If x squared plus 1 is equal to 3x, show that the log of x plus 1 minus half of the log of x equal to a half of the log of 5. I'm just going to pause it now and just set up for the second video. Okay, so I've just unpaused it there. So this is a fairly substantial question here. So solving logarithmic equations. So this is just another question on the tutorial sheet. So if log of x to the base 2 is equal to log of y to the base 5, and log of x to the base 10 plus log of y to the base 10 is equal to 3 over 2, solve for x and y. Okay, so what we're going to do here is I'm just going to start up on top. So the solution, okay, both of the expressions there that we start off with, log of x to the base 2 and log of y to the base 5, they're both equal to each other, but I'm going to let them both equal to a. Okay, so I have log of x to the base 2 is equal to a, so therefore I can re-express that as 2 to the a equals x and 5 to the a equals y. Okay, so we're just moving along nicely. Okay, so what I'm going to do there is we need to work in terms of log to the base 10. So essentially what this asks us to do, essentially this is part of the second part up here, which you can just see at the top. I'll just move it down here a little bit. So I'm going to sort of work with this bit now. Okay, it's going to be a bit fuzzy there, so I'll just push back up. So I need to work in the context of log to the base 10. Okay, so I'm moving from 2 to the a equals x, and I'm going to just sort of get the log to the base 10 of both sides of that equation there where my pen is pointing. So we have log of 2a to the base 10 equals log of x to the base 10. 2 to the a is, when we sort of log of 2 to the power of a, we can rewrite that as a times log 10, log of 2 to the base 10. Okay? And we can do something similar there for 5 to the power of a equals y. Okay, so you end up with a times log of 5 to the base 10 equals log of y to the base 10. Okay, so just using that there, just re-expressing it, or getting the log of both sides and just re-expressing it there. Okay, so now I have an expression for log of x to the base 10 and log of y to the base 10. So we have these two here. Okay, so what I'm going to do actually is, so this is where we're going to pick up. This is what we're told in the question. Log of x to the base 10 plus log of y to the base 10 is equal to 3 over 2. Well, in that case, just substituting in the values we've just derived, a to the log of 2 to the base 10 plus a to the log of 5 to the base 10 is equal to 3 over 2. Okay, so I'm just going to sort of move this down to the next page here now. So that's the last page. So I just sort of remark that this is where we are. Okay, so I just actually take the a out of the equation. So we have a times log of 2 to the base 10 plus log of 5 to the base 10. And just using the basic rules of log multiplication, if we have two expressions like that we can add to, we just multiply them out. Okay, this is the rule multiplication of logarithms. We end up with log of log of 10 to the base 10. So a times log of 10 to the base 10 is equal to 3 over 2. Log of 10 to the base 10 is 1. Anything to the base, the log of anything to its own base is 1. Okay, so simply a times 1 is equal to 3 over 2. So x is equal to 2 to the power of a. Okay, so a is 3 over 2. So x must be equal to 2 to the power of 3 over 2, which is the square root of 8. Okay, and y is equal to 5 to the power of 3 over 2, which is the square root of 125. That is the answer we are looking for. That is that job done. End of tutorial.